How should I use random.jumpahead in Python? I have an application that does a certain experiment 1000 times, multi-threaded, so that multiple experiments are done at the same time. Every experiment needs approximately 50.000 random.random calls. What is the best approach to get this really random? I could copy a random object to every experiment and do then a jump ahead of 50.000 xpid. The documentation suggests that jumpahead 1 already scrambles the state, but is that really true? Or is there another way to do this in the best way? No, the random numbers are not used for security, but for a metropolis hasting algorithm. The only requirement is that the experiments are independent, not whether the random sequence is somehow predictable or so.
You shouldn't use that function. There is no proof it can work on Mersenne twistor generator. Indeed, it was removed from Python 3 for that reason. For more information about generation of pseudorandom numbers on parallel environments, see this article from David Hill.
I could copy a random object to every experiment and do then a jump ahead of 50.000 xpid. Approximately correct. Each thread gets their own random instance. Seed all of them to the same seed value. Use a constant to test. Use /dev/random when you run for the record. Edit. Outside Python and in older implementations, use jump ahead 50,000 xpid to avoid the situation where two generators wind up with a parallel sequences of values. In any reasonably current, post 2.3 Python, jump ahead is no longer linear and using xpid is sufficient to scramble the state. You can't simply do jump ahead 1 in each thread, since that will assure they are synchronized. Use jump ahead xpid to assure each thread is distinctly scrambled. The documentation suggests that jump ahead 1 already scrambles the state, but is that really true? Yes. Jump ahead does indeed scramble the state. Recall that for a given seed you get one long, but fixed sequence of pseudorandom numbers. You're jumping ahead in this sequence. To pass randomness tests, you must get all your values from this one sequence. Edit. Once upon a time, jump ahead 1 was limited. Now jump ahead 1 really does a larger scrambling. The scrambling, however, is deterministic. You can't simply do jump ahead 1 in each thread. If you have multiple generators with different seeds, you violate the one sequence from one seed assumption and your numbers aren't going to be as random as if you get them from a single sequence. If you only jump ahead 1, you'll maybe getting parallel sequences which might be similar. This similarity might not be detectable. Theoretically, there's a similarity. When you jump ahead 50,000, you assure that you follow the one sequence one seed premise. You also assure that you won't have adjacent sequences of numbers in two experiments. Finally, you also have repeatability. For a given seed, you get consistent results. Same jump ahead, not good.
Jump ahead 1 is indeed sufficient, and identical to jump ahead 50,000 or any other such call. In the current implementation of random, I believe that came in at the same time as the Mersenne twistor-based implementation. So use whatever argument fits in well with your program's logic. Do use a separate random.random instance per thread for thread safety purposes, of course, as your question already hints. Random module-generated numbers are not meant to be cryptographically strong, so it's a good thing that you're not using for security purposes.
Per the random module docs at python.org. You can instantiate your own instances of random to get generators that don't share state. And there's also a relevant looking note on jumpahead, as you mentioned. But the guarantees there are kind of vague. If the calls to OS provided randomness aren't so expensive as to dominate your running time, I'd skip all the subtlety and do something like if num_exps is 1000, then you're unlikely to have any collisions in your seed. Birthday Paradox says you need about 65,000 experiments before there's a 50% probability that you have a collision. If this isn't good enough for you, or if the number of experiments is more like 100k instead of 1k, then I think it's reasonable to follow this up with. Note that I don't think it will work to just make your seed longer. os.urandom8, for example, since the random docs state that the seed must be hashable, and so on a 32-bit platform you're only going to get at most 32 bits, 4 bytes, of useful entropy in your seed. This question piqued my curiosity, so I went and looked at the code implementing the random module. I am definitely not a PRNG expert, but it does seem like slightly differing values of n in jumpahead n will lead to markedly different random instance states. Always scary to contradict Alex Martelli, but the code does use the value of n when shuffling the random state.
If you want to sell more, press some hidden subscribing.